students, welcome to today's class. Today we are learn about the first lesson of 7th standard integers. All of you already knew about the definition of the integer as well as representation of the integer on a number line, right? Although we just recall the definition of the integers. What is the definition of the integer? Integer is defined as the set of all whole number with the negative set of natural number. Okay. What is the definition of integer then? The integer is defined as the set of all whole number with the negative set of natural number. Then how will we represent the integers on the number line? First we draw a straight line and mark a middle point and label it as 0. And the left of the 0 you have to mark negative number -1, -2, -3 up to -infinity, and the right side of the 0 you have to mark +1, +2, +3 up to +infinity. Okay, this is the representation of the integers on a number line. This topic is addition and subtraction of integers. We already learned this addition and subtraction of integers in our previous classes, right? Although just to brush up the things in my explanation zone. Before discussing addition of an integer, just recall sign multiplication. What are sign multiplication? See here, plus into plus gives plus only. Plus into minus gives minus, minus into plus minus, minus into minus plus. So these are the sign multiplication, and these are very important in the addition, subtraction, multiplication and division of the integer. Okay. See here, first we add any two numbers. I will take both positive number, okay? 2 plus 3. So it is very easy. What? This one also positive sign, this one also having the positive sign. So positive is positive only. Plus 5. Okay. Next, one negative and one positive. I will take -7 plus 2. See here, we will write -7 as it is, and 2 is also positive, so plus only. Then minus plus is what? Minus plus, we have to take the sign multiplication. Minus plus is what? Minus plus is minus. But here we have to minus these two numbers. We have to minus means subtraction. We have to subtract these two numbers. 7 minus 2. What is coming? 7 minus 2. 5 is coming. And see here, we will subtract 7 minus 2. Then the greatest number having which sign? No, that sign you should write before this number. Here greatest number is what? 7. So that greatest number having minus sign, minus you have to write. Then third example, I will take one positive number, another one negative number. Plus here we have to add these two numbers, right? So 2 plus of -3. I will write 2 as it is. Then plus minus is what? Plus minus minus. -3 we have to write here. 2 minus 3. Here 2 means plus sign is there. Plus minus is what? Minus. But what you have to do? you minus these two numbers, you subtract these two numbers. 2 minus 3 or 3 minus 2, what is coming? 1 is coming. So the greatest number having which sign? Minus sign. You have to put minus here. Next, fourth one, I will take both minus sign number, minus 5, then plus of minus 2, because this is addition. I will take addition sign here, and both are negative number. Minus 5 as it is you have to write. Plus minus, what is this? Plus and minus, minus 2. Then minus minus, what? Minus minus is plus. What you have to do? You have to, plus means you have to add these two numbers. What is coming? 7 is coming. So the highest number having which sign? Minus sign. You have to put minus sign. Explanation zone. I hope that all of you are clarified about the addition and subtraction of an integer, right? Okay, let's move on to the next topic, properties of an addition and subtraction of an integer. Property is closure property. What is this closure property? If any mathematical operation performed on member of a set produces member of that set itself, symbolically represent the closure property as A star B is equal to C. Here A and B are member of a set. Okay, star means any mathematical operation is performed between two numbers of that set that gives the what result C. This also be a member of that set itself. Okay, this will clarify the closure set, right? Then in the case of integer, how will we define the closure set? For any integer A and B, then A star B is equal to C belongs to Z. Here A and B are any two integers. If any mathematical operation performed on that integers give the result C, right? So that result is also belongs to integer set itself. Let's study about closure property under addition and subtraction. Here we have to check integers are closed under addition and subtraction or not. We will deeply discuss all these things in my explanation zone. Here I will explain closure property under addition as well as closure property under subtraction. First, closure property. As I said before, operation on members of the set always produces member of that set itself. See here, if A and B are any member of a set, then it produces the member of that set itself, right? So in the case of what integer, what will happen? See here, in the case of integer, A and B are any two integer. For this, any mathematical operation is performed between these two integers gives an integer itself. Next we prove closure property under addition. This is very simple. In the place of star, we have to use addition sign because it is under addition, right? So here we use the operation addition. A plus B is equal to C belongs to Z because A and B also integer and the result is also integer. We will prove one by one. I will take one example. 2 plus 3. Here 2 is also integer and 3 is also integer. What is the answer? 5. And 5 is also integer, right? So what? 5 is also integer. Hence integer is closed under addition. We will prove another. Okay, we will take another example. We will take negative numbers here. Minus 23 and plus 3. What is the answer? Minus 23 plus 3 is minus 20. So this minus 20 is also belongs to Z, right? Therefore what? Integers are closed under addition. Hence this proves that integers are closed under addition. Therefore closure property under addition is satisfied. Closure property under subtraction. In this property, the subtraction of any two integer is always an integer. That is what? A minus B is equal to C is also belongs to what? Z. We will prove by some examples. We will take examples here. 18 minus and B I will take minus 24. Then what is the answer? We will know the sign multiplication and we will know the subtraction of integers, right? So see here, 18 we have to write here only as it is. Then minus into minus is what? Plus. Then 24. 18 plus 24 is what? 42. 42 is what? This is integer, right? 42 also integer. Therefore 42 belongs to Z. Then I will take another example. Minus 16 minus of minus 46. See here. Minus 16 I will write as it is. Then minus into minus we have to write plus. Then 46. Then minus plus is what? Minus plus we have to know the sign multiplication, right? We will know the sign multiplication. Minus plus is minus, but we have to minus here the number. We have to subtract the numbers only. What is the subtraction of 16 minus 46 or 46 minus 16? 30, right? So 30. Then which sign we have to put here? A sign multiplication. It is comes minus, but we will not put the minus sign here. We put plus sign. Why we use plus sign? Because the greatest number having the plus sign. Therefore we will write plus sign. So this plus 30 is also belongs to Z. Therefore integer is always closed under subtraction. From the explanation zone, I hope that all you are clarified about the closure property, right? Okay, let's move on to the next property, that is commutative property. This is commutative property. The commutative property is one where the result of an equation must be remain same despite the change of the order of operands. We represent the commutative property as A star B is equal to B star A. Here we despite the change of the order of operands, right? Here first A star B is there. Next it is what? Changing the order as B star A. Although it changes the order of operands, the what result are same. Then only it satisfies commutative property. We will deeply discuss commutative property under addition and subtraction in one explanation zone. Here we will discuss commutative property under addition and commutative property under subtraction. As I said before, commutative property is what? Commutative property is one wherein the result of an equation must remain the same despite the change in the order of operands. See here, I will write here symbolic representation of commutative property. A star B is equal to B star A. Even though despite the change of the operands, the result must be remains the same, right? Like this property is called what? Commutative property. In the case of integer, for any two integer a and b, then a star b is equal to b star a. That means if any two integers, we can add the integer or we can subtract the integer. If despite of the change of the operands, it will remains the same. Then only it will satisfy the condition. Okay. Now let's we study about the commutative property under addition. What is the commutative property under addition? In this property, the addition of any two integer when interchanged gives the same answer. What is that? A plus b is equal to b plus a. Okay, let's prove here. We'll take one example here. Minus 23 plus of 32 is equal to 32 plus of minus 23. I will just change the order of operands here. Minus 23 plus 32 is what? Minus plus is minus only. You have to subtract 32 minus 23. What is coming? 9. And the highest number having the plus sign. So I will write plus only. Here 32 minus 23. Plus minus is minus. So 32 minus 23 is what? 9. So here both answers are same. And one more example I will take. 4 plus of minus 2 is equal to minus 2 plus of 4. Plus minus is what? Minus. So you have to subtract these two numbers. 2 is coming and the greatest number having the plus sign. Minus 2 plus of 4. What? You have to subtract these two number. 2 is coming and the greatest number having the plus sign 2. So here both answers are same. Hence commutative property is closed under addition. Commutative property is what? Closed under addition. Now commutative property under subtraction. I will give some example. We will prove it by example. Okay. First one. 8 minus 5. Then 5 minus 8. 8 minus 5 is what? Plus minus is minus. We have to minus it. What? 8 minus, subtract these two numbers. 3 is coming, right? Then 5 minus 8. Plus and minus. What minus? You have to subtract the number. But here highest number having which sign? Minus sign, negative sign, minus 3. And plus 3 and minus 3 are both are same? No, right? Then both answers are different. So it is not equal. Therefore 8 minus 5 is not equal to 5 minus 8. I will take another example. Minus 20 minus 3. Then 3 minus of minus 20. Here we have to prove for subtraction. So I will write the subtraction sign here. Minus 20 as it is. Minus plus is minus 3. Minus minus plus. You have to add these two numbers. 23 is coming. And greatest number having the negative sign. And here minus 23, right? So here 3 minus minus is plus 20. 3 plus 20 is 23. Here minus 23 is coming. Here plus 23 is coming. Both answers are different. So Hence, by observing these two examples, we can say that what? Subtraction of any two integers a and b when interchanged does not give the same answer. Hence, what it will becomes? A minus b is not equal to b minus a. Hence, integer not commutative under subtraction. Let's move on to the next, associative property. What is this associative property? Associative property is one where the result of an equation must be remain same despite a change in the order of operators. We will represent it by symbolically as group of A star B star C is equal to A star group of B star C. We deeply discuss associative property under addition and subtraction in my explanation zone. Associative property. Before I discuss about associative property, I will write symbolic representation of associative property, that is group of A star B star C is equal to A star of group B star C. See here, as I said before, associative property is one where the result of an equation must remain the same despite a change in the order of operators. Here order of operators is changed, right? See here, in the case of what? Integer, how we will define? See here, for any three integers A, B and C, then A star B star C is equal to A star of B star C. The first case is what? Associative property under addition. What is the associative property under addition? Whether it is satisfies the condition, we will see by taking one example. I will take one example. Minus 3 plus of minus 2 plus of minus 5 is equal to minus 3 plus of minus 2 plus of minus 5. Then minus 3 plus of minus 2. See here, minus 3 plus minus is what? Minus 2 plus of minus 5. Then minus 3 plus of minus 2 plus minus is what? Minus 5. Then minus 3 minus 2 is what? Minus minus plus. We have to add these two, 5, and the greatest number having the negative sign. Then plus minus is what? Minus. So minus 5. Next, minus 3 plus of minus 2 minus 5 is what? Minus. We have to minus minus is plus. We have to add these two numbers. 7 is coming. The greatest number having the negative sign. So see here, minus 5 minus 5. We have to add these two numbers, 10 and the negative sign. The greatest number, both are numbers same. So we have to write the negative sign. Here minus 3 plus of minus 7. Minus 3 plus minus is minus. See here, minus 3 plus minus is what? Minus 7. Minus 3 minus 7 is what? We have to add these two number, 10. The greatest number having the negative sign. Both are what? Same. Hence, integers are associative under addition. By observing the example, we can say that addition is associative for integer. That is, sum of 3 or more than 3 integers, sum of 3 integers. Here we will taken only 3 integers, right? The sum of 3 integers remains the same on changing the grouping of the number. Here the grouping of the numbers, what if we change the grouping of the number also, the what results are same, right? Hence the integers are associative under addition. From the explanation zone, I hope that you all are verified about the associative property, right? We go on to the next topic, additive identity. What is this additive identity? See here, a plus 0 is equal to 0 plus a. That gives what? A, right? So here, if 0 is added to any integer, it gives that integer itself. So it gives what? Same integer itself, right? So therefore 0 is called as additive identity. Let's move on to the next topic, additive inverse. What is this additive inverse? What you added to a number to get 0 is called what? Additive inverse. I will give us several examples. Here plus 2 is the additive inverse of what? Minus 2. Minus 2 is the additive inverse of plus 2, and plus 2 is the additive inverse of minus 2. That is, plus 2 plus of minus 2 is equal to 0. What you added to get 0 is called additive inverse. See here, plus 2 is there. We have to add minus 2 if you want to get 0. That's why minus 2 is additive inverse of plus 2. Okay students, I will briefly tell you what we have learned today. Definition of integer, representation of an integer on number line, addition and subtraction of an integer. Properties of addition and subtraction of an integer. Under this we will study about closure property, commutative property, associative property, additive identity, additive inverse. This is all for today. We will discuss the remaining topic of integer in the upcoming video. Thank you.